Hello students, welcome back. So in this session, I'm going to be talking about Pandas data frame, more specifically dealing with statistics. So the prerequisite for this is that you should be knowing the meaning of mean, median, mode, these types of values. Mean, median, mode, standard deviation, outliers, percentile, correlation coefficient between variables. So these are the terms that you should be at least aware of. You should know the meaning of what they mean. So pandas, they allow us to calculate these values. Okay, so let's do some of the example. Let's see how it does that. I import my pandas as PD. So let me copy this, and put it over here. And I import my pandas as PD. I'm creating an alias, and I'm calling this PD. And then I'm calling my data file. Now make sure you have this data underscore tips.csv. This file, by the way, is located in the same drive, same location where you got this lesson statistics. All right, let's run this. And it worked fine. Okay. All right, great. Now, let's read that file, data tips. So this contains a data set for tips. People go to restaurant, okay, they spend some money. This is their total bill. They pay some tips, okay. This is the amount of tip they paid. And sex, this actually is a gender, whether it's a male or a female. Smoker, whether did they smoke or not. Day, whether it was Sunday, Saturday, or Thursday. Time, what time was it? Was it lunch? Was it dinner? Size, how many people were there in the group? Were there 2, 1, 4, and so on and so forth. So this information is present inside data types, and we're going to try to understand a little bit more about this data set using statistics. First thing we do, we print our shape. Okay, so this is going to give me how many rows and how many columns there are, and you can see there are approximately 244 rows and 7 columns. Okay, uh, let me see if I can change the theme to dark high contrast. All right, there you go. So it sees that there are approximately 244 rows and 7 columns. All right. Let me change the theme for this to high contrast. All right. Now let's find some information about the columns. So let's do that. I print df.info. This is going to give me information about the columns. All right. So if you look at the columns, it's telling you that these are the columns: total bill, tip, sex, smokers, days, time, size. And you can see that from here too. These are the columns. It also tells you there are total 244 entries. And it even tells you that out of the 244, 244 are non-null, meaning the values are present inside this column. For total bill, there are 244 non-null values. And what type of data type that is? It's a float, 64-bit. Tip, this column actually has 244 non-null values. And what type of data type that is? Float 64 bits, and so on and so forth. This one, time, is 244 non-null. And object basically generally refers to, it's a string kind of variable. Okay. Size means in this case it's an int variable, 64 bits, and there are 244 non-null entries. It even tells you the memory usage, like it's taking 13.5, approximately 13.5 kilobyte of memory is being used in this data frame. Okay. Now give me the stats on each numeric columns. I want the stats on each numeric columns. So in this case, columns is equal to total bill, tip, and size. These are my numeric columns. So if you come over here, you can see total bill, tip, and size. These are numbers, right? So these are your numerical columns. And you can also see from here, right here, numeric columns, and numeric columns. So these are your numeric columns. Okay. Now I run this, and it gives me the stats on each numerical column. Okay, it tells me that the count for total bill is 244. The mean value is 19.78 for total bill. So this right here, total bill, this column right here. Okay, this one, the mean value for this column is 19.78. The standard deviation is 8.9. The minimum value is 3.07 and the maximum value is 50.81. This 25%, 13.34, this one. This means that 25% of your data, it falls below 13.34 for the total bill. 50% of your data, it falls below 17.79. And 75% of your data falls below 24.12. Now let's look at the size. 244 count, mean value is 2.56, standard deviation is 0.96, and minimum value is 1. So it tells me the size of the people. For minimum people were 1, and the maximum size is 6. Now remember, size is integer. You see, size is integer. Okay, and same thing with tips. You can actually read the same thing with tips right there. It's very descriptive. This actually gives you the mean value, standard deviation, minimum, maximum, and these percentiles. Okay, these are your percentile numbers. All right. Now let's do column-wise statistics. All right, let's do column-wise statistics. So let's do for only one numeric column, total bill. Let's calculate the mean value. Okay, I print my mean value. This is how you calculate the mean value. Okay, then let me just actually comment everything out. Okay, I calculate my mean value. This is my mean value for total bill. Okay, what about the median value? You can also calculate the median value, 17.795. What about the standard deviation? You can also calculate standard deviation like this. This is your standard deviation. And likewise, you can calculate minimum, maximum, and sum. Okay, minimum, maximum, sum. It gives you each one of the corresponding values. You can also find the most common occurring value. Remember, mode tells you the most common occurring value. So the most common occurring value for the tip, I want to see that, what that number is, 2. It seems like a lot of people, they give a tip size of 2. That's the 2 rupees or $2, whatever the unit is. But it seems like 2 is a very common one. All right. Now this one, I was only doing statistics for only one column. Maybe I want to do for every single numeric column. Let's do that too. So step 2, I want to run the stats on all the numeric columns. These are my numeric columns. Okay, total bill, tip, and size. What I'm doing, I'm running through a for loop. So I'm basically doing the same thing right here. I'm just doing the same thing, except now I'm doing it inside the for loop. I'm just going through iterating over each one of these numeric columns. If I run this, and it's going to give me for each one of them stats for total bill. Okay, this is my first one, stats for total bill. Done, done right there. And these are my mean, median, standard deviation, minimum, maximum, sum. So these are my corresponding values. Likewise, stats for tip. Okay, it gives you stats for tips. And likewise, you have stats for size right there. Okay, now show me the unique counts and the values for column. These are the columns: sex, smoker, day, time, size. I want to see the unique values and also values for these columns. So let's do that. Let me copy this. Come over here. Print it. Okay. And let me remove this right now. Okay. So these are my columns. I want to know unique counts. Okay, let's run this. And it gives me the unique count. For sex, there are only 2 unique values. For smoker, there's only 2 unique values. For day, 4 unique values. For time, 2 unique values. For size, 6 unique values. All right. I want to know what those unique values are. So let's find that. I want to find the unique values. So the way you find, you say for call in columns. Okay, I am writing a little for loop and I'm calculating unique value for each one of the columns. And the way you do for each one of the series, I'm sorry, and the way you do, you use this method called dot unique. Okay, and when I run this, it's going to give me unique values. So for sex, remember there were 2 values. What are those? Right here, it tells me male and female, or female or male. For smoker, 2 unique values, no and yes. For smoker, 2. For day, it was giving me 4. Okay, for day, what is it? Saturdays, Sunday, Saturday, Thursday, Friday. For time, dinner and lunch. Size, this was the size. How many unique values were there for size? 6. And there you go, 2, 3, 4, 1, 6, 5. So this is my size unique values. Now I want to know how many values are there in each one of them. Okay. I want to know how many values are there in each one of them. So I want to know how many females are there, how many males are there, how many no's are there, how many yeses there, how many Sundays are there, how many Saturdays, Thursday, Friday. I want to know the count of each one of them in essence. So let's do that. So there's a way you can do it. There's something called value counts. And that's going to give you the value count for each column. Let's run this. And there you go. And you can see the value count. Okay, let's look at this. Male for the sex purpose. Male is 157 and female is 87. All right, for smoker status. No is 151 and yes is 193. And likewise for days, Saturdays 87 Saturdays, 76 Sundays, and 62 Thursdays, and so on and so forth. All right. Now I want to find Q1, Q2, Q3, IQR, and outliers. Assuming that you know what these values are, what these means. If you do not, then make sure watch my tutorials on Q1, Q2, Q3. That'll give you an idea. So the way you calculate Q1 is you type DF, total bill, for this column, dot quantile 0.25. Okay, likewise you calculate your Q2. Q2 is your basically 50th percentile. Q3 is your 75th percentile, not percentage, percentile. And then I print my Q1, Q2, Q3. And then I calculate my IQR. IQR, if you remember, if you know, would be Q3 minus Q1. That prints out my IQR. Then I find my lower and upper bound. So my lower bound is Q1 minus 1.5 times IQR. This is my minimum value. Okay, this is my lower bound. And likewise, my upper bound is going to be Q3 plus 1.5 times IQR. Then I print my upper and lower bound, and then I find my outliers. Now, my outliers are the points that are below lower bound or that are above than the upper bound, which are greater than the upper bound or less than the lower bound. Those are my outliers. And I print my outliers. Okay, this is I get my outliers. And then I display my number of outliers. So it gives me the length of outliers. Okay. Oops, let me maybe something happened over here. All right, there you go. I print my outliers and it gives me the length. So total number of outliers is, oh, there should be F over here. All right, let's run this. And total number of outliers is 9. Okay, there are 9 points that has total bill smaller than lower bound and total bill greater than upper bound. Okay, and these are those points. So these points are exceptionally kind of like in terms of total bill, their value is a little bit either too high or too low. That's what it's saying. So these are my outliers. Now let's check for some null values. You can also check for some null values. Okay. Let me just come over here. Put this over here. All right. Now let's check for some null values. And let's create some cells. Okay, I run this. And that's going to give me null value. So it's telling me total bill has no null, has null value 0. Tip has null value 0. I mean, in other words, everything is 0. So in other words, there is no empty or null values inside any one of these columns. Now I want to find the correlation coefficient. So I want to find the correlation coefficient between the numeric columns only. So if I run this, it gives me the correlation coefficient. In this case, I want to find the relation between tips, total bill, and size. I want to find any relation, if there's any relation that exists between these three of them. So this is the way to do it. And then the way you read this, let's look at this value right here. It's telling me that the correlation coefficient between tip and total bill is 0.67. Okay. Likewise, the correlation coefficient between size and tip is 0.489. So the closer your correlation coefficient is to 1, that means they are strongly correlated, strongly positive correlated, meaning one variable goes up, the other one also goes up. If they are negative 1, they are strongly negative correlated. One goes up, the other one goes down. If they are zero, that means there's no correlation between them. They are basically all over the place. Okay. All right. Thank you, gentlemen.